So thanks for being here. I hope you had a lovely break. So in this speech, we are going to explore together this fantastic world of these tools, the API gateways. But let me do a little bit of introduction first on who I am. My name is Giorgia Fiscaletti. I am an Italian computer engineer, and I'm currently working at Mia Platform as a cloud engineer. So what do we do at Mia Platform? We have one of the very first products in the market to create and develop Kubernetes applications. It is an internal developer platform, and it was a product that was created by developers for developers to help companies deal at best with their digital transformation. And as a cloud engineer, I am currently working in the R&D team. And what we do on a daily basis is do some research on possible evolution of our platform and our product, new tool to be integrated in our platform, new ways to automate and optimize our infrastructure, and so on. But let's get to the main content of today's chat. So we will start with a little introduction on API gateways. We will see what they are and why are they so important for our applications. Then we will get to explore a selection of a few tools, a few of the most popular tools from the Cloud Native Computing Foundation. We will see the main features, we will get to compare them, and finally, we'll get a closer look to a few features that were essential in our use case, and we will get to see how they were implemented in the different tools that we will see later on. But let's start from the very beginning. So I guess that pretty much everyone, maybe of you are familiar with API gateways, but I always ask the question. So how many of you already know what an API gateway is? Just raise your hands. All right. Pretty much everyone, but let's do a little review, shall we? So what is an API gateway? As the name suggests, it is a gateway. It is a portal. It is the entry point to our architectures. And they help us managing the inwards and outward traffic. So in a few words, what an API gateway does is when a request arrives from a client with a specific URL, the API gateway is the entry point. So it takes this request in charge. It performs some checks that may be, I don't know, authentication and authorization checks, other operations that may be in the plugins that are implemented in our API gateway. And then, most importantly, it helps the system map the URL with the correct microservice, with the correct underlying microservice. So it picks, depending on the URL, the correct microservice, the correct underlying microservice, and then returns the response to the client. They will be very happy with that. So let's give you a little bit of background. Why are we talking about API gateways today? So to answer that question, we need to go a little bit back in time. I hope you get the reference from the GIF here. A little bit back in time to 1 year ago, when I was asked in my company to perform a little research to change our API gateway. We were looking for a tool that was a little bit more performant and more extensible with respect to the one that we already had at that time. So it was my very first time dealing with this kind of research. I was very excited with that, but I barely knew what the Cloud Native Compute Foundation was at that time. I barely knew what the acronym stood for. So I was asked to go to the CNCF landscape page and to look for a few tools to compare them, see their features, and try to understand which one was the best fit for our use case. So you probably all know the CNCF landscape page. So I found myself in front of this, and if you read over there on the top, it says overwhelmed, and the answer is yes, definitely overwhelmed. And this was my very first reaction. Once I put my glasses on, I realized that I didn't have to analyze all of these tools, but we had two big macro categories that were of our interest, which were service proxies and API gateways. But if you take a closer look, it's still a lot of tools. It's more or less like 40 tools. At that time, there were 40. I don't know how many they are right now. So you need to do, in a company, you do not always have the time. When dealing with a product, you do not always have the time to perform an in-depth analysis on these numbers of tools. You have to do some filtering, some selection. And as a take-home with this presentation, I hope to leave you with some piece of advice, some hints. If you ever find yourself in a situation where you have to pick new API gateway for your application, being it a new application that you are developing, or being it a situation where you are changing the API gateway of your applications, as it was for our use case. So let's summarize the few things that we already said. What are API gateways? They are one of the core elements of our applications, since they are the entry point to our microservice architectures. And as we already mentioned, they help us managing and orchestrating the traffic with the outside world. Then they help us ensuring performance, since a performant API gateway means that we are reducing the latency of our requests. They help us ensuring availability and also scalability, since what the client sees from the outside is just a black box. It just sees the API gateway as an entry point, and then behind the API gateway, we can keep adding as many microservices as we want. And this procedure is completely transparent to the end user. Finally, last but not least, they help us enforcing security, thanks to the integration which is essential with authorization and authentication services. Let's get a little bit more in the core of today's presentation by comparing these two macro categories that we can find in the CNCF landscape, which are service proxies and API gateways. Starting from proxies. Well, proxies aren't API gateways by definition. They are more generic tools that can be implemented in many different ways, be it, I don't know, a security proxy, a canary, and so on. So the API gateway is just one of the many implementations. This means that we can build our API gateway from scratch. We have a blank page. We can build an API gateway that perfectly fits our needs, even integrating some features that may not be obvious or straightforward for an API gateway. But being this extensible often means that we have a higher underlying complexity. We have a slower learning curve. We may need a little bit more time studying the documentation, building the tool, and so on. On the other side, we have API gateways. These tools have a targeted implementation. They are built with the only purpose of working perfectly well as API gateway. This means that they're generally, from my experience, less complex and maybe a little bit less extensible, but this is not necessarily a disadvantage because we just have a well-defined set of boundaries in which we are sure that the tool is going to work perfectly as an API gateway. So I put here a list of a few tools that I had the opportunity to analyze. From on the proxy side, we have Envoy Traffic, Contour, and Nginx. And on the other side of the API gateways, we have Emissary, Glue, Kong, and Tyke. I personally picked 4 among these tools, and we're going to have a close look of the noteworthy features of these tools in a few minutes. So, starting from Envoy. How many of you already know Envoy? They already dealt with it? Okay, great. So Envoy is a high-performance C++ service proxy, or as I like to call it, the final boss of service proxies, since many other tools are built on top of Envoy. So among its noteworthy features, we can remember that we can say that it is an out-of-process server, meaning that it can be implemented in any environment. It is completely independent from the environment it is built in. So this means that we have quite the freedom to build it pretty much everywhere. Then it has support for both HTTP2 and gRPC, also HTTP3 from one of the latest versions, meaning that we have more freedom when implementing our connections. Then it has a massive extensibility. We can have features that range from more straightforward one, like, I don't know, compression and decompression with gzip and broadly libraries, from more or less obvious one, like fault injection, AWS, GCP, authentication, and I don't know, maybe one day it will help us make coffee and remember when we parked our car. And finally, last but not least, even though writing Envoy configuration might be a little bit tedious, it has a very efficient configuration management that helps us when helps us with the dynamic configuration, since we can upload new configurations without restarting the service. Let's go to the next one, which is Traffic. Traffic, how many of you already know Traffic? Raise your hands. Yeah, it's pretty popular, actually. Its stack is very popular, and it is personally a tool I would picked just for the icon. It's very cute. And it is an HTTP reverse proxy and load balancer. And first of all, it has a very smooth integration with other components, meaning that we can easily integrate it with our platform and with many different technologies. It provides automatic service discovery, which means that we do not have to explicitly map all the URLs, all the routes to our underlying services, but we can let traffic do it for us. Then it comes with automatic HTTPS via Let's Encrypt, which is very useful. And finally, last but not least, I know that we are all very affectionate with our terminals and our CLI, but I assure you that having a clear web UI when dealing with an API gateway is quite useful. Let's get to API gateways now, starting with emissary ingress. Emissary is a specialized control plane for Envoy proxy, meaning it is built on top of Envoy, and it gives us a layer of simplification when writing Envoy configuration. It is Kubernetes native, so it comes with all the advantages of being Kubernetes native, including the possibility to use Kubernetes custom resource definition to write configurations. And finally, last but not least, it is a stateless architecture, meaning that it does not have to be built as a centralized entity, but it can be distributed, and therefore we can distribute all the management of security and availability. Finally, GlueEdge. GlueEdge is another tool that I will personally pick just for the icon. It is a Kubernetes native next generation API gateway. Again, it is another control plane to build an API gateway with Envoy. It is Kubernetes native, so it comes again with all the advantages of being Kubernetes native, including custom resource definitions again. It offers the extensibility of Envoy, so all the stable features in the Envoy proxy. It has support for hybrid applications, meaning it can be easily integrated with different technologies in our infrastructures, being them, I don't know, Kubernetes, Docker, and so on. And finally, it has, again, similarly to traffic, fully automated service discovery, meaning that, again, we do not have to explicitly map all the routes to the underlying services, but we can let Glue do it for ourselves. So let's dive deeper right now. Let's get to the real core of today's presentation, and we will get to see a few of the features that were essential in our specific use case, and we will get to compare how they were implemented in all these tools with a closer look on the Envoy implementation, which was the tool that we picked for our specific use case. Starting with the most straightforward one, which is URL mapping. An API gateway, it is essential that it should be able to map a URL to the underlying microservice in order to redirect correctly the request to the correct service underneath. And this usually comes with this other feature, which is URL rewriting. So an API gateway needs to be able to rewrite the URL, because we do not always want to expose the APIs, the routes from our underlying microservices to the outside world. So this adds a layer, we can say a layer of security, allowing us not to expose the routes to the outside world and letting the API gateway rewrite the routes in order to have them be accepted by the underlying services. So this is implemented in quite a similar way in these different tools. In Envoy, we have a route configuration where we can define a list of matches with their specific URL, the cluster, so the upstream to which we are mapping the URL. Eventually, we can rewrite the URL, we can rewrite the path, the prefix, we can do a regex rewriting, and so on. And we can do even other operations like adding or removing others, and so on. In traffic, we have the router element, which is in charge of giving us the possibility to map URLs to the underlying services. And we have a middleware that is in charge only for, that can be used for rewrite these URLs to URLs that are accepted from the underlying services. In the API gateway side, with emissary, we have a custom resource definition, which is the mapping CRD that allow us to define a list of matches, similarly to Envoy, where we can define, again, the URLs, the underlying services to which the URLs are mapped, and eventually the rewrites. And Glue, similarly, it has this virtual service custom resource definition that maps the virtual host that is mapped to the virtual host of Envoy. And inside the virtual service custom resource definition, we can define, again, a list of matches with the URLs, the underlying service, and eventually the rewrite. Let's get a closer look to how it is implemented in Envoy. I personally highlighted this first match, which is an example. In this case, we are matching through a specific path, meaning that the request needs to have that specific path to be mapped to the underlying service. So if a request arrives with the /API/echo URL, it will be mapped to the echo server upstream. Then, since this echo server upstream, for some reason, just exposes the /echo root, the Envoy is going to rewrite the prefix, and it's going to change /API/echo to just /echo. And as an additional feature to make it a little bit more spicy, I just added a header, and just in case we want to forward some information to the underlying service. You can also remove headers at different timeouts and so on. In the second example, it's a very simple example. I just wanted to show you how you can perform a match even with a regex. So here we have these regex over there, which is I think Envoy uses the Google engine to perform operations on regex. So any string that maps matches this pattern will be mapped to the cluster called Hello Server. Let's get to another essential feature, which is rate limiting. Rate limiting is essential since it allows us to ensure the availability of our applications, and also to help us dealing with denial of services attacks. What rate limiting does is just it allows us to set a limit on the number of requests that can be performed in a specific amount of time on a specific key that could be, for example, the client IP. So, for example, the number of times a user can reload a single page. So we can say that a user can reload the login page like 1,000 times per second. And if this threshold is overcome, the user will receive a 429 error code. So the implementation is pretty similar in both the proxies and API gateways. Envoy offers the possibility to implement both global and local rate limiting. The global rate limit allows us to implement an external rate limit service to which we will get all the configuration. And like, for example, as I said before, the number of requests per time unit on a specific key. And the local rate limit is internal to the Envoy API gateway and allows us to enforce a further limit. They often come combined, since thanks to the local rate limit, we can enforce a further limit, a higher limit, in order to avoid in case of heavy traffic spikes, that the external rate limit service is overwhelmed by requests. In traffic, we have rate limit middleware, which allows us to define, again, the configuration that we already mentioned. So the number of requests, the amount of time for the limit, and also it allows you to set bursts to handle heavy traffic spikes that occur in a very short amount of time. Concerning the API gateways, they both expose the Envoy API, and they, thanks to the rate limit service in emissary and the virtual service custom resource definition in Glue, you can implement a connection to an external rate limit service, similarly to Envoy. So let's get a closer look to how it is implemented in Envoy. It is quite a simple configuration here. On the left side, we have the listener configuration, where I just configured the name of the cluster of the upstream that is in charge of performing the rate limit service, and just a domain that will be simply matched with the domain in the in rate limit service configuration to know that that is the configuration that we are currently applying to our system. And in the rate limit service configuration, this one specifically is the configuration of the Envoy rate limit service. We can define some descriptors. In this case, we are applying rate limit on the remote address, so on the IP address of the client, and we are defining that that specific client, so that specific IP can perform at maximum 1,000 requests per second. Then let's get to another essential feature, at least it was essential in our use case, which is API key management. An API gateway should be able to handle all the definition and the application of secrets. So it should be able to extract secrets from either a header or a cookie and to perform some logic on it in order to apply these secrets on the correct routes. So as far as I'm concerned, from my experience, I realized that it can be implemented. It's a little bit tricky, but it can be implemented through header manipulation, both in Envoy traffic and emissary. And finally, Glue offers a secret custom resource definition, which allows us to easily define secret and apply them to specific routes. So this is an example of how we implemented API key management in our API gateway. So on the left side, we have this header to metadata filter, which allows us to select to extract the secret, in this case, from a header. You can also extract that from a cookie. So in this case, we are extracting the secret from the header called secret header, and we are saving it in the dummy metadata. Metadata in Envoy is some data that can be exploited and leveraged throughout the whole configuration. And in this specific case, if the header is missing, we are saving the value missing in the metadata. On the other side, we have a Lua script that is simply performing some logic on the secrets. In this specific case, we have 2 random secrets that are mapped to a client type and just a key that tells us if the request was possessing a secret or not. So it says secreted if the request had a secret header. It says unsecreted if the secret header was not present, and it is wrong if the secret header did not match one of those two specific secrets. How can we use this information? We can use, for example, an airbag filter. And in this specific case, we have a simple policy that's called deny wrong. And in this case, we are allowing all the requests that are in possess of a valid secret header, or all the requests with a missing secret header, but we are denying all the requests that have a wrong secret, so a secret that is not contained, in our case, in the Lua script, in the Lua configuration. Finally, last but not least, we have authorization. An API gateway needs to be able to perform authorization checks on the request. So it needs to be connected in some way to an external authorization service, or it should give us the possibility to implement an authorization service. So the implementation is quite similar throughout all the tools. In Envoy, we have an external authorization filter. In Traffic, we have a middleware, which is in charge of connecting to an external authorization service. In Emissary, we have the out-service plugin. And finally, in Glue, we have the possibility to build a custom authorization service. Concerning the Envoy configuration, the Envoy configuration is pretty straightforward. In this snippet, we can see that we are connecting to this cluster, so this upstream, which is our authorization service that is called, with a lot of fantasy, authorization service. And what we do, we're performing some operations before forwarding our request to our authorization service. In this specific case, we are adding 2 headers. The first one just saves the path of the request in a new header. The second one picks the client type from the metadata that we saved before in the Lua filter. And finally, we can perform many other different operations. In this case, we are saying that header, an header called some outc header, can be forwarded down to the upstream. So we can add header, we can remove headers, we can save metadata, and so on. So we can do a lot of things to integrate ourselves with our external authorization services. So this is a wrap-up of what we saw in this comparison. So we saw these different features and how they were implemented both in the 2 service proxies and the 2 API gateways there. So yeah, we can go to the conclusions of today's presentation. So we started talking about API gateways. We discovered that there are some essential tools to our application, since they help managing and orchestrating the traffic that goes into our applications from the outside world, and therefore they help us exposing services securely. Then we went through a comparison of a few Cloud Native Computing Foundation tools, ranging from service proxies, which are generic and very extensible, and API gateways, on the other hand, that have targeted implementation and well-defined set of boundaries in which we are sure that we are building a perfectly functioning API gateway. So this is the big question: which one should I pick for my architecture? Well, the answer, as always, is it depends. My 2 cents here may be that if you have some time to study the documentation, if you want to build a tool that perfectly fits your needs and that maybe has some, I don't know, less straightforward features, maybe you should go with a service proxy. On the other hand, if you want a tool that has a targeted implementation that is focused and that has the only purpose to be built as an API gateway, and you want a well-defined set of features to implement your API gateway, and maybe you have a little bit less of time, you want less complexity, maybe you should go with an API gateway. So this concludes today's presentation. I don't know if we have a few minutes for questions, maybe. And also, if you want to know more about MIA platform, you can come join us, me and my lovely colleagues over here. We have a stand down there if you haven't already done so, even if you want to ask a few more questions about the presentation and everything. Also, we are looking for a developer advocate, so please apply. Thank you very much.
Thank you, Giorgia.
Thank you.
We do have time for one question.
So how do service meshes relate to API gateways and service proxies?
Sorry, what?
Service meshes, so like Istio and things like that.
Oh, service meshes.
Yeah.
So,
could you maybe talk a little bit how they relate or not relate to?
yeah, they are quite related to API gateways and service proxies. Actually, service meshes usually offer you a wider range of features and different implementation. They often offer you a stack of different. So usually you have API gateways and proxies included in service meshes. So this is quite the relation between them. I don't know if this answers your question.
Yeah, it's just fairly new on the block, I suppose, compared to. Yeah. I suppose they're fairly new compared to API gateways and service proxies?
Yeah, maybe, I don't know.
Maybe I don't know what I'm talking about.
Maybe, I don't know if I can answer this question. Yeah, I don't know.
Thank you, yeah.
Yeah, sorry.
We can accept this answer, don't worry.
Okay, great.
Any other questions? Oh.
Hi. What are your thoughts about Kong? And because Kong provides all sorts of features like API key management, so you have
of course.
routes with a key, and you have all sorts of other authorization plugins, and also it is kind of a Kubernetes-native.
Sure.
Yep.
I had the opportunity to analyze Kong when I did the research for our company. I think it is a very valid tool. The only thing is that it wasn't the best fit for our needs. I don't quite remember why. But yeah, it wasn't. We analyzed all the features, and at the end, we were looking for something. We wanted to start from scratch. We wanted to build something like from a blank page, literally. So we went with Envoy because it was a service proxy. It was very generic, very extensible. But I think that Kong is a valid alternative. Anyways, thank you very much.